control for semantic web and policy management. She has been also a visiting research scientist at the University of Texas for the last 3 years. Her research and her publication interests include access control mechanism, policy management, data privacy, anonymization, personalization for semantic web technology. So I'll leave you with this as we can.
And the goal of this work, and then I'll explain consent management model, and I'll illustrate the model with a case study example, and finally I'll mention about the future work, future directions of this work. And we all know that remarkable growth in digitization of records brings great advances for consumers, and sharing personal information, especially in the domains that handle with sensitive information, brings privacy risks for consumers. For example, one of them is linking attack. What is linking attack? Linking attack is the leakage of a crucial, important information by integrating leased and publicly available data sets. The knowledge that can be inferred from this sensitive information may unveil the consumer's personal information. And according to the study of 1990 US Census summary data, 87% of the individuals in the United States are identifiable with their gender, age, date of birth, and 5-digit zip codes of their addresses. Thus, consumers must control the access to their personal information and give consent to others whom they want to permit the access. Consent management is a policy that allows a consumer to determine rights for a provider's access request to her personal information. On the other hand, the balance between the personal privacy and the quality of service should be ensured. The goal in consent management is protecting privacy according to personal consent policy and stimulating information sharing to improve the quality of personal data usage for specific acceptable reasons. But we don't want to make excessive distortion because it would lead to the specific loss in analytical validity. In this work, we use medical domain. Medical domain is one of the crucial domains to realize the importance of consent management. And patients are the subjects of electronic health records. And they have the right to know who accesses their data and who is collecting their data, who is processing their data. And so health information systems must protect the patient's consent rights. As every person has different preferences for what happens to their data and who access the data, each patient may demand different privacy levels for their electronic health records. The goal of this work is to define a semantic web-based personal consent management to protect consumer privacy while endorsing the information sharing for personal data usage. And as I mentioned, we use the healthcare domain for this purpose, and each patient can specify her own consent data according to her personal privacy needs and create personal consent policy. And each access request to her electronic records are executed according to her personal consent policy, As a result, the decision of the access request should be a permission or a prohibition. And we combine the access control techniques with personalization, and it's based on semantic web technologies. And the user manages the access to her own records and controls the privacy of her data. And in order to give the user full control of her own data, user data is differentiated into two directions. One is quasi identifiers, and for the healthcare domain, the other is medical data. Quasi identifier is a set of attributes in a table which can be linked with external information to re-identify the individual's identity. The personal consent management model consists of these shown sets. Subject is the owner of data that is going to be accessed, and user is an entity who wants to access the subject's data and perform operations on it. Each user and subject has a role in the domain. For example, in the medical domain, this can be a nurse or a doctor or a lab technician. Organization is an entity where the user is an employee of, and action indicates the operations that the user wants to operate on an object. Actions can be updating, viewing, or deleting a record. In the model, all subjects are also using the actions in order to define what operations they will permit or prohibit. Object is the entity that the user is going to access and perform operations on it. And in the medical domain, user patients' medical records are our objects. Also, objects are subjects' consent data. Quasi identifier, as I mentioned earlier, is used to limit the definitions of an entity, to limit the privacy requirements value on an object. And constraint is a condition which is used to limit the definitions of an entity related with the policy object. Purpose indicates the intentions of the user on an object. And policy objects define which actions are going to be processed and under which circumstances and for what purposes. Policy objects can be a permission or a prohibition. Permission means what the user can do, and the prohibition means what the user cannot do. And consent data policy is the subject's policy definition to finalize the access decision. The access request is formed of this tuple: user, subject, object, action, and purpose. Consent data policy is the response to the access request, and it is is represented with a tuple of subject, user, policy object, and consent data. Consent data set is a pair of subject quasi identifier or subject objects, and policy object is formed with the role, action, purpose, and constraint. The model is described with DL, atomic concept language with complements, and by including qualified number restrictions. And it has this shown concepts: subject, user, role, organization, action, object, quasi identifier, purpose, policy objects, consent data, and consent data policy. It has also atomic roles. Has role links the user and subject to a role. Is an employee links the user with an organization. Is owner of and has owner are the inverse roles, and they create a link between the subject and its object. Has request links the user with the subject and subject's consent data. Has consent policy links the subject's consent data to user's access request. Has consent links the subject's consent with the policy objects. Has constraint links the policy objects and action with constraints. And has quasi identifier links the subject with the quasi identifier set. And finally has action links the policy object with an action. And consent management model rules can be shown using these forms. Every subject and every user has a role in the domain, and some users are employments of an organization, and every object has a subject owner, but some of the subject has an object. And some subjects has quasi-identifiers and some subjects has consent data. Every policy object has an action, and consent data is formed with subject and its quasi-identifiers or its object. User, subject, object, action, and purpose forms the user's request. And subject, user, policy object, and consent data forms the subject's consent policy. Roles, action, purpose, and constraint forms the policy objects. Permission and prohibition are policy objects, and they are the complements of each other. For the case study, we illustrate a practical example for the medical domain, and the syntax is used as from the previous slides. In the case study, Bob has a role as a doctor, and he is an employee in medical city hospital, and Bob is doctor of Mary, and Bob has patient. Mary here is doctor of and has patient are the equivalent roles. Mary has a role as patient, and Mary has doctor Bob, and she is patient of Bob, also is patient of and has doctor are the equivalent roles. Mary is owner of blood test, and she has quasi-identifiers as the name, gender, date of birth, social security number. Bob makes 2 requests, and he wants to publish his patient Mary's quasi-identifiers and blood test results for his research purpose. So he's sending 2 requests for each of them, and he indicates his research purpose and the other concepts in his request. And Mary defines 2 consent data concepts. For one of them is for blood test, and the other one is for her quasi-identifier. Consent data 1 is for her quasi-identifier, and consent data 2 is for her blood test. And she permits her doctor to use her blood tests for his research purpose, but she prohibits him to use her quasi-identifiers for his publication. And the final response of Mary to Bob will be 2 consent policies. The first one is prohibition, which includes the quasi-identifier publication, and the second one permits the permission and permits the doctor to publish her blood test results for his research purpose. So in this manner, Mary can control who can access to her personal records and for what purposes these data can be used. And she can categorize her records as consent data and determine access levels according to her according to the request purpose. Eventually, she allows the usage of her personal data while protecting her privacy. So in the personal consent management model, users can manage who is accessing their data, which part of their data, under which circumstances, and for what purposes they are accessing. And users not only protect their privacy, but also contribute to improve the quality of the personal data sharing for acceptable specific reasons. And as a future work, this consent, we will implement this model's ontologies, and it will be queried and tested. It will be queried to execute and test scenarios of the model, and the roles in the consent management model will be represented by using FOAF profiles, and finally, a reasoning engine will be developed to demonstrate the use of consent policy rules.